There are several components of an independent digital lesson, each designed to ensure students experience a balance of procedural fluency, conceptual understanding, and application work. Students work through each component of the digital lesson at their own pace, giving every student the time they need to deeply understand new content they are learning. Let's walk through the components of Lesson 6. All digital lessons begin with Number Gym, an individually adaptive fluency activity that helps students learn and practice foundational number sense. In this activity, students work on decomposition and making the next 10, starting with concrete practice using a 10 frame. Using visuals they can move and manipulate, students grapple with sophisticated number strategies. As they show understanding, the 10 frame is taken away, and they can transfer their understanding to solve more difficult problems with bigger numbers. These activities help students reinforce previously learned concepts and address any areas of unfinished learning. Next, students do a lesson-aligned fluency. These activities support students' grade-level learning by reviewing previously learned concepts and preparing for upcoming content. This particular activity develops fluency with addition and subtraction of multi-digit numbers, keeping place value strategies fresh and building deep understanding of the base 10 system. Next, students move on to guided practice, where they learn and practice new concepts. In this lesson, students are beginning to learn multiplication and division, and the math chat helps students build an understanding of the connectedness of the two operations.
Hey there, mathematician! Let's get started with the word problem. Read this problem and imagine what's happening.
Math chats resemble a small group setting where students learn with their teacher.
Kayla?
We know there are 20 total fish, and 5 fish can fit in each tank. We're trying to find out how many tanks they'll need for all 20 fish.
You got it! Here is one tank. Let's start by putting 5 fish in this tank. Keep going.
Students begin by visualizing the problem to help them make meaning of the problem and understand the mathematical work required to solve. During independent digital lessons, students visualize problems with rich animations, like these fish, and construct their own visual models using high-quality digital manipulatives. This approach helps all students build flexible and accurate problem-solving skills that they can apply across different problem contexts. As students work through the problem, digital manipulatives provide in-the-moment feedback that helps students test and confirm their thinking. Here, students are asked to relate the known parts of the problem to a multiplication equation, and then relate their multiplication equation to a division equation. As students work with pictures, animations, concrete objects, and digital manipulatives, they develop a deep understanding of what the abstract symbols mean and the relationship between the different operations.
Let's solve this next problem in your notes.
In each guided practice, students transfer their learning to paper using student notes, drawing their math and representing their thinking in a variety of ways. Here, students are prompted to draw a pictorial representation to solve. As students problem solve in their notes, software-based prompts help them check and self-correct their work. At the end of this math chat, students write a multiplication and division expression to show how they found the value of this unit. After guided practice, students demonstrate their new learning in the Tower of Power. In the Tower of Power, students work through multiple stages of independent practice, solving problems that become more complex and less scaffolded as they progress. Students need to answer all questions correctly to complete the Tower of Power and unlock the next lesson in the mission. This tower begins with a concrete model to determine the unknown number of groups, and progresses to using a different strategy, an array, to solve the problem. If students get any part of a problem wrong during a digital lesson, they get personalized, embedded remediation that provides just the right amount of support. Remediation support breaks down the question into smaller steps with more supportive manipulatives that allow students to understand and correct their mistakes. Then, students demonstrate understanding on a new problem. If students continue to struggle after multiple remediation paths, teachers are alerted in class reports and have precise visibility into where students need differentiated support.
This right here is one.
Throughout the digital lesson experience, Zearn aims to represent the diversity found in classrooms across the country, so all students can see someone similar to themselves learning math and persevering through challenges. We also strive to make our digital lessons accessible for all students, in line with our mission to ensure all students love learning math. Digital lessons include closed captioning, audio supports, and keyboard accessibility intended to provide support for a diverse range of learners.